Hello everyone, welcome back to another video, and in this video we will be taking a deep dive into one of the most used packages in Python, and that is Numpy. Now, first of all, why Numpy, and why do we really need to know Numpy? As a data scientist, we encounter a lot of problems where we need to compute large amount of data, and we need to put some sort of a computation over it, or we need to somehow manipulate it or somehow reshape into something else. And this is exactly where Numpy comes in. Numpy is basically a computing package for Python, which is basically used for applying different operations on multi-dimensional arrays. Now, don't worry if you don't understand what multi-dimensional arrays is. We're going to be taking a deep dive in this course, and this course is going to be solely focusing on NumPy's functionalities that can be used in different scenarios in data science. And as a data scientist, you'll be using this library more often. So this is exactly why I've created this course, so that you can actually take a deep dive into what NumPy is and how we can use NumPy for different sorts of things like the error manipulation and so on. So beginning with using NumPy or simply importing NumPy in your Python environment. So what you can do here is you can just go ahead and type import NumPy as np, and if you have everything installed correctly, NumPy is just going to import right away. And otherwise, if you don't, what you can do is you can just go ahead and type pip install NumPy, and if you don't have NumPy installed, it's going to go ahead and check for NumPy whether it's installed. You can see that I have this requirement satisfied, and you can see it says NumPy is already satisfied here. Okay, so which means that I have NumPy installed. Otherwise, if you don't, you can just type this command and install NumPy. Okay, perfect. Let's begin. So beginning with the first thing, which is ND array in NumPy, and NumPy is basically the heart. The ND array is basically the heart of NumPy. And what I mean by that is that whatever we will be doing is we will be performing different operations on something called ND array. ND array is the heart of this library. So what is ND array? ND array stands for n-dimensional array. And what n means, n refers to a number. Okay, so an array could be a one-dimensional array, or array could be a two-dimensional, a three-dimensional, four-dimensional, and so on. So what does it mean to what does it mean for an array to be one-dimensional? In simple words, you might have created a list in Python, and it must look like this. So this right here is called a vector, or simply a one-dimensional list. So it only contains one dimension, where these numbers represent a linear space, right? So these numbers are representing a linear list, that's it. So how do you make this two-dimensional? Well, one way would be to actually go ahead and create a list inside a list, and this would make this list instantly a two-dimensional list. Or maybe what we could do is we could just go ahead and, let's say, I'm just going to go ahead and create this populate a little bit more, and then what we could do is we can copy this two-dimensional list and put another list right here and put them inside another big list. So this would be a three-dimensional list. That's what you might be thinking right now. Okay, so if you just go ahead and print this out, this list out right here, you can see it's perfectly working in Python. But how do we do this in NumPy? Well, it's as simple as this. We can just go ahead and say np.array, and right here, what we can say, we can just say np.array, and here I will just pass in a list just like Python, and just print this out using the print function. And if you just print this out, you can see it's working. Awesome. So we just created our array using NumPy. And if I try to try to see what it does and whether it was created using NumPy, what I can do is I can just go ahead and use the function type and put an a here, and you can see it says that the array that we just created is basically an ND array, which means it's an n-dimensional array, and it's a NumPy type of array. But how do we know which data type this matrix contains? Like, you can clearly see that we're using integers here. We're not using float. So how do we know that? Well, a simple way to find that out would be to use something called d type, which is a property in NumPy. So if I just go ahead and say so I have an a dot. So I can just go ahead and say d type, which refers to the data type, and then I can just go ahead and try to print this out, and you can see it tells us that the data type used in this matrix is int64. which is basically the size or simply the memory that each and every integer consumes in this array. Okay, so far so good. Now there are different properties that you can use of an array, and we need to understand what are the different types of array we can create, and what are the different properties that we can use to find out what type of array it is. So I'm just going to go ahead and create a simple matrix using Numpy. I will just say np.array, and I will just go ahead and put in a list here, and I will put another list inside a list, and I will just say 1, 2, 3, and then comma. Right here I will just go ahead and create another list right here, and I will just go ahead and put 1, 2, 3. Okay, this looks like a matrix, right? So we can kind of see that we have a 1, 2, 3 in one row, and we have another row, and we have 3 columns. But how do we know what shape? Let's say it was a very big matrix, and you didn't want to count the number of rows or columns. How would you know that what are the dimensions of this matrix? Well, in simple words, Numpy provides us a property which is called shape. So we just go ahead and type shape here. It's going to give us the shape of the array. You can see the shape is 2, 3, which represents that we have 2 rows and 3 columns. Awesome. So let's try to change this and put let's say another row here. I'm going to call this 1, 2, 3. Let's just go ahead and change this number to 4, 5, 6. Okay. So now if I just print this out, you can see it says 3, 3, which is simply a 3 by 3 matrix. Alright, so you can kind of get the idea how this is all this is actually putting them in place. Awesome. So with that being said, we have the shape, or simply the shape property right here, is one of the properties that you can use in this using Numpy, or simply one of the properties that you can call from this array. But this is not just the one property that you have. Now Numpy provides you with a lot of properties. So if I just go ahead and type in A here, you can see it will give you a lot of properties that you can use for this type of an array. So you can see that one of the properties that we used was shape here, and it simply just goes ahead and returns the shape of the array. You can also use other types like the dtype property that I just used to find out what data type are we using this array, and so on. And you can see that it has a lot of other properties as well that we will be slowly taking a look at in the further examples. Okay. So one of the properties that Numpy has, which I think you should know, is the size property. So if I just use the size property, you can see what it gives us are the number of elements, irrespective of what dimensions the array is in. It just gives us the number of elements, and you can see that it simply is it's just counting the number of elements in this array right here. So the size property just returns the number of elements in the whole array, or simply the whole matrix. Okay, perfect. So now one more property that we can use here to instantly find out whether this array is a 2-dimensional or a 3-dimensional or a 4-dimensional array. We can just go ahead and use the NDIM, which is simply stands for n-dimensional array. And if I just print this out, it says that it's a 2-dimensional array. And why so? Well, in simple words, we just discussed previously that creating a 2 by 2 array, or simply creating a 2-dimensional list, only requires putting a list inside a list. So you can see that right now we have a main list, and inside we have 3 different lists, or simply sublists. Okay, and this is exactly why it's a 2-dimensional array. So let's see how can we create a 3-dimensional array. Okay, so a basic approach that I would be using would be to actually go ahead and putting a square bracket right here, and then I'll just go ahead and put this right here, and I will copy this array right here, this simple array. This is a 2-dimensional array, right? So I will just copy this one, and right here I'm going to put a comma here, and again put this right here and close this. Okay, so now we have created a 3D array. In order to find out if whether this is really 3-dimensional or not, I will just go ahead and run this command again, and you can see it returns a 3, which means it's a 3-dimensional array. Now, how do we find out how many dimensions do we have in this array? So I'm just going to use the shape property again here and see what we have. What do we get? Okay, so we get 2, which simply tells us that we have a total of 2 2 by 2 matrices in our array. So you can see, if I just go ahead and put a little space here, we have a 2 2 by 2 matrices, and then each one is a 3 by 3. So you need to start from here. So the shape property returns the first bracket right here, which is stars, which is like a hierarchy. So the first main list, or simply the main array that we have, is this one right here. Okay, so these two are the first ones. So it returns the dimension, or the number of elements inside this this list right here in the first element right here. Okay, in the tuple, and the second element represents the number of rows in each 2 by 2 matrix, and then the number of columns, and so on and so forth. So if I just go ahead and create a 4-dimensional or a 5-dimensional array, the hierarchy is going to continue here, and similarly we will have a 4. So it's going to start from 5, 4, 3, 2, 1. That's how the shape works. Okay. Now we know how the shape works, and now we know how the size works. We've explored some of the properties of how we can actually go ahead and find out different properties of an array. But how do we actually go ahead and, now I'm going to go ahead and take a look at how we can perform basic operations using Numpy. Okay, so let's begin with the basic operations. So first of all, I'm going to go ahead and use the basic operations of Numpy to create arrays, and there are not one but there are many operations in Numpy that we can use to create different arrays, different sorts of arrays, and we'll be taking a look at each and every one of them. So one of the most easiest operations that I can think of right now is, let's just go ahead and create another array. I'm going to call this one B, and I'm going to say np dot 0. So if I just go ahead and press tab here, it instantly gives us a function which is called zeros. And let's if you take a look at this zeros. Okay, so what is the usage of zeros function here? A zeros function in Numpy creates an array or simply a matrix filled with zeros of any shape. So let's say if I pass in a particular shape in this zeros function here, let's say I pass in a 2 by 2, and let's try to print this out as well. So you can see what it does. It creates a zeros array, a matrix for us, a 2 by 2 matrix for us filled with zeros. One thing that you notice here is that we have a decimal point with each element here, and that is because the basic operations, or the basic functions in Python, or I'm sorry, the Numpy, return the elements as float. So we need to like change the data type of them. So one way to change the data type is to pass a D type right here, and I will just go ahead and pass in int 64. You can use int 32 as well, and this creates an array of integer zeros instead of float zeros. Okay, awesome. So now, as you can see, you can pass in any shape in this function, and it will instantly create a matrix for you with that particular shape. Or what you could do is you can just go ahead and say, let's say you wanted to actually create a 3-dimensional, so I could just pass another dimension right here, or like this, and you can see it creates two 2 by 2 matrices. It creates two 2 by 2 matrices for you, and it's that simple, right? Awesome. So with that being said, I can actually go ahead and create a linear array as well by just passing 10 here, and it creates a linear or simply a simple list for you filled with zeros. And so Numpy doesn't only create doesn't only provide functions like zeros, but we have also a lot of other functions like there's also one more function that we can use. I'm just gonna go ahead and copy this one right here, and I will just go ahead and paste. This one right here is called the ones function, and this one creates an array filled with ones. Just like we had zeros, we have filled with ones. So why do we need these functions, and what are the use of these functions? Like why would I need a function like this in any real world application? Well, if you have ever worked with images before, or if you have ever worked with image processing before, Numpy is very good at these things, because simply if you recall the basic concepts, well, an image is simply a big representation of a 3-channel matrix, right? So manipulating that matrix using these functions become very easy. So Numpy provides us the functions that could be used to manipulate those images. Okay. With that being said, I also remember more functions like so there's another function called np.arange. So arange function is kind of similar to how the range function works in Python, and you can actually define a range, or a range in which the number should be generated. So what I could do is I could just go ahead and say 4 comma, let's say I'm going to go ahead and say 0 comma 10, and then I'll just go ahead and print this out, and let's see what happens. So you can see what it does. It just goes ahead and creates an array for us in a particular range, starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see that the 0 here is as inclusive, and 10 is exclusive. So that's why it starts from 0 and ends at 9 and doesn't go till 10. So whatever number right here is, let's say if the number is here is n, the array is going to be generated with n minus 1 values. Okay, perfect. So now we have that done. So now we know the basic functions. What we can do here, now there are other many options available in basically changing the shape of arrays, or simply changing the way how arrays work, right? So right now you can see that we have an array of 10 values. What I can do specifically is I could just go ahead and reshape this array. So we recall the shape property that simply returns the dimensions, or the rows and columns of an array. So we can reshape this list right here to look like a matrix by changing its shape into like a 2x2 or 3x3 array. So if you see that we have total of 10 values here. So let's try to reshape this into some other matrix, or let's try to manipulate this one. Okay, so I'm going to go ahead and type in 2 comma 2. Okay, and let's see what happens. Okay, I did that on purpose right here. Why do we have an error? It says that we cannot reshape an array of size 10 into a shape 2x2. Well, if you recall, if you multiply 2 into 2, I'm just going to comment this out right here. If you multiply 2 into 2, we get a total of we get a space of 4 elements, and we have 10 elements. So we need a matrix that could fit all 10 elements in it. So, well, what matrix what matrix fits 10 values in it? Well, one matrix that I could think of is a 2 by 5, which fits exactly 10 values. So let's try that and let's see if that is true. If I do that, you can see it works. Awesome. So now if I just go ahead and print this out, you can see that it instantly reshapes our matrix into a 2 by 5 matrix. Or we could just go ahead and change the dimension by saying that we have 5 rows and 2 columns. So that just goes ahead and does this. Clean, right? So you can see that how easy it is to actually manipulate matrices or play with matrices in Numpy. Alright. So there's another function in Python, in Numpy, that you can use to generate a sequence of numbers, and that is called there's another function called linspace. And linspace kind of works similar to how arange function works. It still takes the first 2 arguments. Like for example, if I just go ahead and say np.lin and linspace, and then if I just go ahead and say, so it takes the first 2 arguments, like the initial and end values of the sequence, but the third argument in the linspace, instead of specifying the distance between one element and the next, define the number of elements into which we want the interval to be split. So let's say I wanted to generate an interval or simply a sequence of numbers. So what I could do, I could just specify 0 till 10, and then let's print this out. So it prints out all the sequences. You can see there's a difference between this. So you can see that I started from 0 and it goes all the way up to 10, but it increments with a very, very small value. And this is exactly why we have so many numbers in just a sequence of 0 till 10. And that is because if I just specify, now we can actually go ahead and specify an interval after which an element occurs. So I can specify 1, and that will generate the interval from 0 till 1 as 1, because we have only one value. Now I can just go ahead and pass in 2, so you can see it goes from 0 to 2. I can go ahead and pass in, let's say, a 50, and this will generate a sequence for me which is of 50 numbers. And we can actually go ahead and create a sequence that starts from 0 till 10 into any big sequence that you want to. Let's say if I specify 1000 here, it's actually going to generate a sequence for me that goes all the way from 0 till 10 by iterating through every single point value and going all the way up to 10, and that actually creates an element for us which is of 1000 numbers. So using so you can kind of get the idea that we can actually generate these kind of sequences to to especially in where we want to create plots, right? So if you have ever worked with matplotlib or any other plotting library in Python before, usually those libraries take a sequence or simply the coordinates on which the plot should be created or simply plotted on. So you can use these kind of functions to actually define a sequence of scale or simply the x or y scale of a particular canvas. Okay, so with that being said, we now have a basic idea of how these operations work. I can think of another operation which is np.random, and this is also a pretty useful operation, especially if you're creating a random array. And what it does is it simply just goes ahead and takes a shape of a matrix, or simply you can pass in a 3x3 or you can pass a 3-dimensional or 2-dimensional array in this one as well. So if I just go ahead and pass in, let's say, a 3x3 here, and just go ahead and print this out, it says the random takes one positional argument. Oh, okay. So what does that mean? Whoops, I forgot to add the space here. There we go. And you can see that it creates an array of 3x3 with random numbers. And why do we have these points is because we haven't specified in what range the number should be. We can actually specify how do we want the matrix to be, or we could specify this to be a float. So if I just go ahead and specify d type to be an integer 64 and print this out. Whoops. So it says that the d type argument is unexpected. Okay, so I think this one doesn't receive the d type. Let's try the ren here. Oh, so I think we have a problem here, and that is because this function doesn't take the d type. Okay, so this function actually works in a way that it actually just goes ahead and generates random numbers all the way from 0 till any number, and it's a 3x3 number. So that's how it works. Awesome. So we now have an idea of how these functions work. We're actually going to take a look at now. We're now actually going to take a look at how the arithmetic operators work on Python. Okay, so we now have the idea of how the basic operations in Python work. Now I will just go ahead and take a look at the arithmetic operations in Python. Okay, let's start. So I'm going to type in this right here as arithmetic operators, and right here I'm just going to go ahead and create a random array here, and I'm going to call this array as np.arange, and right here I'm just going to go ahead and put a 4, and let's try to print this out. And you can see that we have an array of 4 elements starting from 0 and ending at 3. Okay, awesome. So how do you perform the operations on these arrays? Let's say I wanted to multiply this this array right here with a 2. What we can specifically do is we can just go ahead and put a 2 here, and if I just print this out, you can see that it's as simple as this. You can now add or multiply or subtract this array with any number, and the effect will take on each and every element of this array, and it simply just goes ahead and iterates over each and every element and multiplies it with 2. Or you can just go ahead and now apply any operation here. Let's say you wanted to add or subtract this array, so you can add it to, you can do any operation right here. Okay, so with that being said, now let's try to actually go ahead and let's try to see how we can actually go ahead and use apply operations on different matrices and actually add or subtract 2 matrices together in Numpy. So I'm going to go ahead and create a very actually a fair good looking matrix here, and I'm going to call this array, and right here I'm just going to say 1, 2, 3, and then I will go ahead and create another one. This is going to be 4, 5, 6, and then another one which is going to be 6, 7, 8. Oh, I'm actually going to go ahead and say 8, 9, and 0. Okay, perfect. That's not a good looking matrix, but I think that's good for the job. And I'll just go ahead and create another matrix. I'm going to call this one B. Okay, so let's just make sure that there's no problem here. Okay, so both of them are actually created. So now we have everything in place. Now let's try to actually perform what we call in Numpy as or simply in mathematics as element wise operations. Okay, Okay, and what we will be doing here is that we will be actually adding and subtracting and multiplying two matrices together. And in NumPy, it's as simple as just typing A plus B. So what you can see here is that we have a result of the addition of these two matrices, and NumPy makes it so easy for us that we can actually specify an n-dimensional matrices, and NumPy is going to quickly add them for us together, and now we can apply any operation. Now let me show you one thing. Okay, so if I just go ahead and multiply A into B, you can see if you have ever done matrix multiplication in mathematics before, you might realize that this is not the right result. And the usual way how you multiply two matrices together is you first go ahead and take the first row and multiply it with the first column of the other matrix, right? And you can see this one right here, it doesn't seem to be the right result. And the reason for that is we are doing what is called the element-wise operations. So what it does, it simply just goes ahead and grabs each and every element in the array, and picks the same position element on the other matrix, and this simply just goes ahead and apply an operation over them. So right now I'm just doing that, okay? And further, when we will be moving on to the advanced operations, I will be teaching you how you can actually go ahead and apply the actual multiplication that actually takes place in mathematics, okay? So right now we're just taking a look at the element-wise addition, subtraction, and multiplication. All right. So now what you can kind of see here is that what we can do is we can actually apply different mathematical or mathematical operations over this matrix, or we can go ahead and just, let's say I wanted to create another array. I'm going to go ahead and say I'm going to go ahead and create another matrix here. I'm going to say np.arange, and right here I will simply just go ahead and say 0 till 10, and then I have a matrix created. And then what I can do is I can just multiply this whole thing with np.sign of a. Sign of r, because we are multiplying it with the same thing. And let's see what's the result. So you can see that the NumPy provides us with the scientific functions as well. So we can use the sine theta, or the sine or cosine functions to actually multiply or simply create a range of wavelengths simply in a particular interval, or we can actually go ahead and easily create those things using NumPy's built-in functions that are available. And if you really want to know what are the different functions available in Python in NumPy, you can just go ahead and type in help here and just pass in np, and what it is going to return for you is a range of I don't know how much time it's going to take to return all of that. I'm just going to go ahead and say np dot I think this is not giving us the right okay, never mind. I think what you need to do is you need to just pass in that in a function in a terminal, and it's going to work. So as you can see that the things that we have available are crazy, because there are a lot of functionalities available for us in NumPy that we can use to calculate different things. Okay, perfect. So now we know how different functions in NumPy can be used to perform different operations. We can now move on to a little bit more advanced operations that we can apply in matrix. So now one of the advanced operations that I can think of is called the matrix product. So now remember what I told you about how we need to multiply these two matrices together, but the result was not right of the A into B. So right now I'm going to show you how we can do that. Right? So how do we actually how do we perform the real multiplication between two matrices? Well, it's as simple as that. So I'm going to go ahead and take a dot product. Now, what is a dot product, first of all? In NumPy, the dot product could be understood as simply multiplying each and every matrix by first picking up the row and then multiplying with each and every column of that. So this is kind of product. Instead of using dot product, you can actually go ahead and multiply the matrices with the element-wise operation, or you might even use the simple for loops to perform the actual multiplication. But we wanted to perform this directly, so we can use a dot product here, or simply the dot function here. The dot function takes the the dot function can be used as a as a function or simply a property of one matrix, and then we can pass in another matrix and multiply them together. And you can see now we get the correct result of these two functions, of these two matrices. You can see right there. Okay. So, okay, perfect. So now I'm actually going to go ahead and try to change the size of this, and you can see that this one, this right here, it still works. And that is because it takes now it's going to go ahead and add, it's going to go ahead and just simply go ahead and add more and more rows, or simply add more and more elements, or simply stack the elements right next to each and every list of there. So you can see how the Numpy works here, right? With that being said, there's another way of actually how you can actually use the dot function here, and that would be to use np dot and just pass in both of the matrices like this. I'm just gonna okay, this one's going up, so you can see that now this one also works in the similar way like the previous one. Okay, so now we know a lot of functions and a lot of different mathematical operations that we can perform. One more thing that I can think of is the increment and decrement operations on the matrix that you can perform as well. So what I can say is increment and decrement operations on matrices, right? And if I just go ahead and say A is equals to, actually I'm just going to use the original matrix that we created right here, and that what I will do here is I will just go ahead and say print A plus equals 1, and let's see what we get. Oh, so we have an error, and that is because, oh, I'm sorry, we are actually using the assignment in the print function. So I'm just going to go ahead and say A plus equals 1, and I will just run this, okay, and then I will just say print A. So what do we have here? You can see that we instantly added 1 in each and every element of the matrix A, and it instantly just goes ahead and simply just adds 1 to each and every element of the matrix. And you can kind of use this increment or decrement operator over the matrices as well. So by using these functions or seeing these functions, you can kind of get the idea that Numpy is basically providing you with a lot of flexibility of operations that you can perform over a matrix, and it makes things very easy for you. So you don't have to like reinvent the wheel or simply reinvent the whole process or write the whole code or pseudocode or simply the whole algorithm to actually perform an operation. So Numpy provides a lot of built-in functions that you can use as a feasibility in the projects that you're working with. Okay, so now we will be taking a look at what we call in Numpy as the universal functions, and how we can actually use these universal functions to perform different operations. So there are a list of universal functions available in Numpy. Okay, so the first one that I can think of is the square root function. Okay, and what does the square root function does? So we already have a matrix here which is A, so I'm going to use the B one, okay, right here. So now what I can do here is I can say B equals, and I will say np dot sqrt, and then right here I can just go ahead and pass in B again. So what I'm doing is I'm just going to apply a square root on each and every element in B, and then I'm returning the result in the B again so that I can actually update that matrix, and then I'll just go ahead and print B out here. And you can see that we instantly apply the square root on this matrix right here, and it simply works quite easily. And this is one of the universal functions in Numpy. And there are other functions like we also have functions like log. So we also have function that is like np dot log, which simply just applies log over your matrix. Or we can actually go ahead and calculate the sign. We can just go ahead and pass in sign function right here, which is also a universal function. And there are a lot of other universal functions available in Numpy that you can use. Right, and in general, the universal functions in Numpy are basically referred to as the ufunc. Okay, so if you want to like learn more about these functions, you can actually go ahead and move and try to like navigate to the original documentation from Numpy, and you will find a lot of things. Okay, now after universal functions, there are other there are things called, there are some other functions in NumPy that are called the aggregate functions. Okay, and what are these aggregate functions? Okay, let's try to like see what are the aggregate functions. So the aggregate function simply just goes ahead and performs operation on the set of values that are available in NumPy, right? And they're usually going to produce a single result. So if you take a look at this, I will just go ahead and try to print this out. Okay, so aggregate functions print out a single result of your matrix of your matrix. Okay, so I'm just going to use this R function right here, and I'm just going to copy this right here so that it's easy for you to see. And I'm going to run this again. Okay, this one's actually printing out, so I'm just going to remove this one right here. Okay, so we have some problem in our kernel, but never mind. Okay, so what I will do, I will just go ahead and say r.sum, and the sum function will return the sum of our array. So if you take a look at this, we had values all starting from 0 to all the way to 9, and what this function right here does, it simply just goes ahead and returns the sum of all the values in the function in the array. Or if you take a look at this, we had a matrix as well, right? So we can also apply the same function on these type of matrices as well. So if I just put A here and sum it up, you can see it also does the same similar function operation over this one as well. So irrespective of what shape your array or what shape or your ND array is in, you can always use these universal functions these aggregate functions to apply different sort of operations. There are functions. So we have another function called min, which simply returns the minimum value of the matrix, which in our case is actually 1. Or you can also use the max to return the maximum value, which simply gives us the 10. You can see right here. And why do we get 10 here is because we actually incremented this with 1. So I'm just going to go ahead and remove this right here, and let's try to run this again, and you can see now we get 9. Okay, perfect. So which means that all this is working pretty fine. And then we also have other functions such as the mean of the array. So we can apply the mean to actually get the so we are getting like the average of the whole array. So what the mean function does, it simply just adds up all the values of a matrix or of an n-dimensional array, and then simply divides it with the total number of elements present in the matrix or in an n-dimensional array. Okay, so this is exactly what the mean function does. We can even calculate the standard deviation by using the std function, and you can see like these kind of functions can be used in the statistics, or when we are trying to like calculate or simply analyze the descriptive statistics of our data. So these are the functions that we can use using NumPy. Okay, so now we will be moving on to a little bit more advanced topic, which is I think which in my opinion is one of the most useful topics that we need to study before we can actually start learning about we can actually go into data science, right? Or even if you are doing anything in image processing or data science, you need to know this. And what this is called, it's called index slicing. And okay, so we already know a lot about how we create different arrays or matrices in NumPy. So now what we will be applying, we will be actually taking parts of those matrices out by a technique what we call slicing. The slicing is very common, especially if you've already done this in Python or in pure vanilla Python. You might know what slicing is. And what slicing means, we are actually going to go ahead and crop a portion of array, or simply slice a portion of array and return it as another array. Okay, so let's try to actually slice an array. First of all, before slicing, I'm actually going to go ahead and teach you. So I think before slicing, it's important that we know what indexing is, so that it becomes easy for you to actually understand what slicing is. Okay, so what is indexing? All right, so what is indexing? First of all, we already have created a lot of arrays right now. So if I just go ahead and try to just print out this array right here, you can see that we have this array right here. But how do we actually go ahead and get a portion, or simply get a particular element from this array? Well, the general way to do this would be to actually just pass in an index here, and we can just go ahead and pass in 1 here. So what we get is a 4, 5, 6, or we can just go ahead and get an individual element from this list as well by passing in another number. So we get an individual element right here, which is 4, right? This is how we actually go ahead and call an index. Or we can actually use a comma here to get the value, and this also works fine. Okay, perfect. So you can see that it also returns the same thing. So this is how you actually go ahead and get the indexes of your array. Or you could even use the negative indexes as well. Numpy totally accepts the negative indexes as well, and I will just go ahead and pass in 1 comma -1. So you can see how it actually just goes ahead and gives us the indexes, or simply returns the values on these indexes, right? So Numpy accepts the reverse indexes as well. So if you don't know what reverse indexes are, I will just go ahead and try to print out the array here. What you can see here, if you use the reverse indexes, what will happen is it will start from the last, okay? So the negative one, if you take a look at this -1, the -1 should return, right now if you just pass in this -1, it's going to return the last list of this array, right? So if I just, okay, let's try to do this. As you can see, this returns the last list of the array. Now, with the -1, I could just specify that I want the last list and the last element. So right now, what I'm saying is that I want the last list and the last element of that list. Okay. So right now you can see that it returns a 0, and we can actually cross-check by printing out the original array as well. So you can see this is the 0 right here, and it returns the right element. Perfect. So now we know what indexing is. So now we can actually pretty much move on to slicing. Now, until now, what we were doing was you were just getting the individual portions of our array. But how would we get a range of, or simply how we would get a part, or simply a crop a part of our array from the whole matrix, or simply return an individual array from the whole matrix? Well, right now, if you take a look, this is the matrix. So let's say what if I just wanted to get these two lists, or what if I just wanted to just get these two elements from this matrix? So how do we apply slicing over here? So I'm just going to go ahead and use the first example here, and I'm going to say let's use this column. Let's use this column, okay? And what does it return? I'm just going to remove this one here, and it returns a whole array for us. Let's put 1 colon 2, and let's see what this does. So you can see what it does. It just goes ahead and returns 4, 5, 6, which by the way, it's saying that it's just getting the first row and the second. It's just including the first row and excluding the second row. So we only have 1 row remaining. So what we can say, we can just put 3 here, and we get the last 2 rows. And what we are specifying here is that, let's try to write the syntax here. So we are specifying the starting index, and we are specifying the ending index here. Okay. So if you take a look at this matrix right here, if I just go ahead and print the original one right here, so we need to specify what's the starting index, okay, and then what's the ending index of a particular dimension. So if you take a look at the shape of the so currently our matrix is, if you take a look at the shape of the matrix here, our shape of the matrix is going to be a 3 by 3, right? And then what we are specifying here is we are specifying that we want to get, so the first one represents the rows, right? So if you just specify 1 colon 3, we are just specifying the rows, okay? So if I just say A1 colon 3, I'm saying take out the rows in this matrix from 1, which is 0, 1, and then 0, 1, 2, 0, 1, 2, and then get and then return those rows for me, okay? And if I just do that, you can see it just returns those rows for me. But then what if I wanted to want to further slice these rows as well, and try to apply slicing on each and every individual column here, okay? So you can see that this one right here represents the rows, right? So if I just go ahead and try to write the generic form of this, you can see this one right here represents the rows, and this one represents the column. So right now I'm just applying the operations on rows. So if I specify the columns as well, and if I just wanted to get these 1, 2, 3, 4, so if I wanted to just get 4, 5, 8, 9, and just crop the first two columns of this one as well. So what I will just say is start from 0 and go all the way up to 3. So it will go from 0, go all the way up to 2. So it will start from 0 and then 1, and it will exclude the 2. Okay, so I'll just say 2, and let's see what happens. Great, so it works, perfect. So from this you can kind of get the idea that we can actually create a very big, or generate a very big matrix, and then crop portions of that matrix to get a particular or a sliced matrix from the original one, right? All right, so with that being said, now I think it's pretty much clear to you that we can actually use slicing to actually crop a portion of our matrix, and it makes things very easy for us, right? Obviously this is a little bit hard to understand, but once you keep practicing with this, you get very familiar with this, right? And what we can if you just put a single column here, what it tells us that it return the whole thing for us. Okay, so it will just go ahead and return the whole matrix for us. It is equivalent to how we write just the A here, right? So we can either write the A, or we can just specify one column, which is equivalent to this expression right here. Okay, perfect. So now we know what slicing is. So now we can move on another thing, which is called the iteration. So how do we iterate over an array in Numpy, right? Well, iteration is pretty simple, and by iteration I mean we need to use a loop. So I'm going to say iteration, and let's try to actually iterate an array in a Numpy array in using the for loop. So I'm going to say for I in A, and I will just go ahead and say print I, and let's see what it returns for us. Okay. Okay, this is actually getting a little confusing here, so I'm just gonna go ahead and close this one. So you can see what it returns here for us are all the individual rows, and the reason for that is because if you just specify one index here, it's going to go ahead and iterate over the rows and not over each and every individual element. So in order to iterate over each and every individual element, what we could actually specify, what we could do is we could use a flat function. So the flat function is actually going to return every single element of our array. So let's just try to use the a.flat function right here and see what the flat function does. Okay. Okay, so the flat function actually doesn't work like that. We need to use a loop for this. Okay, so I'm going to say a.flat. All right, and then oh, I'm sorry. It's actually not the function. It's actually just the property. So if I just run this, you can see that this is actually an iterator, and we need to use this with a loop. Okay, so I'm going to go ahead and use this with a loop, and if I now run this, you can see now we are able to iterate over each and every individual element in this matrix. So this works fine, awesome. And then we can actually go ahead and try to make. So now we can actually go ahead and use any n-dimensional matrix, and we can essentially use this flat property to actually iterate over each and every individual element of this particular array. Okay, so we are doing very good so far. So now we will be going to another topic in Numpy, which is called the array manipulation, and how we can actually use different functions in Numpy to manipulate an array. Okay, so one of the most common functions that are mostly used in Numpy for manipulating arrays are simply joining two arrays together, right? So you might end up in a case where you might want to merge two different images together, and essentially what I mean by images is that image is simply a representation of matrix. So let's try to do that. Okay, well, let's say I have an image which is just an np array, np.array. Actually, I'm gonna go ahead and create a zeros array. Okay, and then let's say this is one has a 10 by 10. This one is a 10 by 10, and let's say I have another image. I'm gonna call this one image A. I'm gonna call this image B, and let's say this one is of ones. And so right now, if I just go ahead and print both of them together, you can see that both of them are actually have been actually created, right? So now one function to actually join these two images together, or simply these two arrays together, would be a function called np.replace v stack. Okay, now this function actually has a very specific way of joining two different arrays together. The v stands for the vertical stack. Okay, so what we can kind of get the idea from this as we can actually go ahead and stack two different arrays vertically. So consider it as a line. Okay, and what we're doing is we're just putting an array over another array vertically. Okay, so now if I just go ahead and let's try doing that. Okay, I'm going to say image A, image B, and then let's print this. It takes, okay, so we have an error, and the error says, oh, so we need to actually pass in we need to pass them as a tuple. Oh, okay, so we forgot another array, another bracket here, and there we go, boom. So you can see we have stacked these two arrays together, and they kind of look pretty cool, right? It's so easy to actually stack these together. And similarly, we have another function called horizontal stack, which is just simply an opposite of this. We can just go ahead and stack these two arrays horizontally, and obviously the printing right here, or simply the formatting, is not that good in Jupyter Notebook, so you cannot kind of see this, but you can kind of get the idea that it's simply stacked everything in horizontally after the zeros and the ones continued, right? So it kind of goes like this. And why it is stacked ones after zeros is because we passed ones after zeros by passing image. So we can actually go ahead and reverse this and say image B comma image A, and that will just go ahead and change the way how it looks. Okay, perfect. So this is working pretty fine. So this is one way to actually join two arrays together. And another way to actually do another way of joining two arrays would be to perform what we call the row and column stacks. So we don't only have the X stack and V stack functions. We also have something called the row and column stacks. So I'm just going to go ahead and create a random array here. I'm going to call this array np.array. I'm going to put in 1, 2, 3, and create another array. And this one is going to be a B array. Okay, and then I'm just going to call this one, I'm going to put the elements here as 4, 5, 6. Okay, and then there's a function called np.column underscore stack, and right here, if you take a look at this function, what this function does, if you just go ahead and pass in A comma B, let's try to see what happens. Okay, so what it did. So what it did, it simply just go ahead and converted these lists into columns and simply just stack them together so that it creates another matrix for us, right? So what it did, it simply just goes ahead and transposes these arrays and then put them as columns, and then this one as columns as well, and then it forms another matrix for us, right? And similarly, we can do the same operation, which is just simply an opposite for this. We just call the row stack, and it simply just goes ahead and use them as they are as a row, and then creates another matrix of rows. Crazy, right? So you can kind of use these functions to actually create or manipulate a different sort of arrays and matrices to create another array. Okay, perfect. Alright, so we are doing pretty good right now. So we have few more functions that we can use, and I will actually show you how we can actually use them. Okay. So another function that we have is the v split and h split, which simply just splits arrays into vertical and vertically and horizontally. So let's say I wanted to split an array, so I will just go ahead and say np.hsplit, and I will just pass in hsplit here, and I'll just say 2. Let's say I wanted to split A into 2. Let's see what happens. Okay, so we have an error, and we have a very big error. It says array does not result in an equal division. Okay, so what it means that we are trying to split the arrays horizontally, but since we can't divide this array into 2 equal divisions, so it is giving us an error. So let's just go ahead and put another number here, 0, and let's do that again. Okay, so we have all the input array dimensions for the concatenation axis must match exactly, but along dimension 1. The array at index 0 has size 4, and the array at index 1 has size 3. Oh, okay, so we have an error. And let's see what error what error does it what does it really mean. Okay, so let's try to actually create I'm actually going to actually explain why this error actually occurred, right? So I'm going to create a completely new array. I'm going to call this np.arange, and then I will put in a 16 number here. So I'm actually creating 16 values, and I'm reshaping this into a 4x4. Alright, and then what I will do is I will just go ahead and create a matrix. Okay, I will create a matrix. I will just try to actually split this now. Okay, and let's see what happens. I'll say h split, and then I will just put in a right here, and then divide it into 2, and let's see what happens. I will just go ahead and get rid of this one right here, and let's see what happens. Okay, so we have an error again, and the error simply says that we don't have the B and C. Let's just put another whoops, I think that's because of the B and C. So what why are we actually ending up on this error? Let's see. Okay, so I think I just figured out the problem here, and the problem was this little code right here that was actually giving us a lot of problems, and this actually works pretty fine. And the thing is that we just need to use the np.hsplit here, and it just goes ahead and splits the arrays into an array into 2 different matrices that you can see right here. And what it does is actually just goes ahead and just splits our array into two different matrices, right? So now we can actually go ahead and kind of get the idea that if we want to like split this one here into 2, what we can do is we can just go ahead and but the one thing that you need to be careful about these functions, that the matrix that you're splitting into 2 different matrices has to be equal in number of elements, so that it could then split it into 2 different it could split it into 2 different equal parts or equal portions. So let's say right now if you have a list, so the list should have even number of elements, or let's say even if you have a matrix, it should be an even number of it should be an even number of shapes, so it should be an even shape. So let's say if I had like a 3 by 2 or simply so 16 values can only be fit in. So if 16 values could only be fitted in a 4 by 4 matrix, so I'm just going to go ahead and try to create another matrix, and I'll just put in 10 here, and I will say 2, 5, and let's try to split this now. And you can see it gives us an error. It says the array split does not result in an equal division, and that's because a 2 by 5 matrix, although we have an even number of elements in this array right here, it still cannot be splitted because of the shape here, and that is because it's a 2 by 5 matrix that cannot be split because we will have 5 elements on the first row and the 5 elements on the second row, and a 5 is not an even number, right? So it cannot be split into 2. So we need to be careful about how our shape is, and then and only then we can apply h-split or a v-split to split our matrix. But this is actually a pretty powerful function especially if you are looking forward to actually split our matrix into 2 different arrays. Alright, so that's pretty cool. That's working, awesome. Or there's another function that we can use which is called the np.split, and the split function, what it does, well, it just splits our array into so we can actually specify a range or simply an index from where the array should be splitted, right? So what we can say we need to split A, and we need to split from 1 comma 3, and then if I just go ahead and print this out, you can see what it does. It just goes ahead and splits our array into from 1 it splits our array into 3 different portions, and the split starts from 1. Or we can even specify we can even specify the axis from which it should split. So if you just mention like an axis of 1, or if you mention axis of 2, well, it will split either from rows or columns, so we can actually specify that too as well. Okay, so that's working pretty fine, right? So with that being said, I think we're pretty much okay with our array manipulation, because these are all the main array manipulations that you should know before you can use NumPy in actual data science. Like, these are the basic manipulations that you will most likely encounter when you're working with problems like data manipulation or pre-processing or data analysis or machine learning and so on. So with that being said, let's actually take a look at another very important topic in NumPy, and which I would like to call is as array broadcasting. And what this concept is actually pretty simple, and it will not take a lot of time, but this one is actually pretty important, that I feel like I should really teach this to you guys. Okay, let's try this. Okay, let's try to do this. So an array broadcasting has to do with how the shapes of our array is. Remember how I mentioned earlier that you cannot split an array if it doesn't have an equal shape, or if it doesn't have a proper shape. So you cannot even also perform the element-wise or simple other aggregate operations over an array if the array is not in the proper shape. So let's say I have 2 arrays, and I will just go ahead and create these 2 arrays, and I will just go ahead and say a range, and I will just go ahead and actually make this a 4x4, okay? So that it's a little bit easier to understand. Okay, so this is a 4x4. So we have 2 4x4 arrays, and let's try to actually add them up together. And you can see it works pretty fine. Okay, that's working. But let's try to actually go ahead and change this into about, let's say, I wanted to just put this into 10, and I will just say 2x5, and let's try to do this now. It says that we cannot, so you can see that we have an error that says operands could not be broadcast together with shapes 4x4 and 2x5. And that is because the shapes are not matching. So even when you're performing element-wise operation, or you're performing any sorts of operations of two matrices being multiplied or added together, you need to make sure that the shapes of the arrays are matching, or it's possible to actually it's possible that we can actually add them together, right? So it's very important that you do that, and this involves the concept for you to understand. This becomes like something that you need to think of before you can actually perform operations over matrices, and they need to be compatible. And the requirements are this is basically like a requirement of NumPy, that the matrices should be similar in shapes before you can perform any sort of operation over them. Okay. With that being said, I think that is pretty much it for the basics of NumPy that you might want to know before you could start data science. And I think this video might have been a little bit helpful to you in understanding what NumPy is, and how we can actually understand the basics of NumPy, and how we can actually go ahead and move to advanced stuff. So this was like a very basic overview of what NumPy is, and all the basic functions that you might want to know before you start learning data science, or before you even go for machine learning or anything. So this becomes this is like an exercise that I can give you as this is like a homework that I can give you, so you can explore more of the functions and properties that are available in NumPy in different topics here. So there are more operations available. There are even more universal functions available that you need to explore. And as you will be applying more and more operations, and you will be using them in your data science projects, you will realize that you will be learning more and more about NumPy, and you will become very familiar with it, and it will be something that you will be using every day. Okay, so with that being said, I think our lecture, our course, or simply our crash course comes to an end, and I hope you might have gotten something, you might have learned something new from this video. And if you did, Don't forget to subscribe to this channel for more and more crash courses like these, and yeah, don't forget to like and subscribe, and don't forget to share this video with your friends so that they can also benefit from it. And that's it. So, bye, adios.